Hello friends, this video on equilibrium part 28 is brought to you by examfear.com. No more fear from exam. Before watching the video, please make sure that you have watched all the previous parts. Let's start with ionization of acid and base. We've already covered this. We have told that strong acid is something which completely ionized in water. Example H2SO4. And if you see this is a one-side reaction, this is not an equilibrium reaction because almost 99% of the H2SO4 is broken into H plus and HSO4 minus ions. Example, I have one acid, strong acid. This is a strong acid example, which has some molecules with H plus. And the moment I'll show you. The moment I put this in water, what will happen is, all of them will break into H plus and the other ions. So H plus ions is almost 100% of these broke into H plus ions. When you talk about weak acid, only partially, so it may be 10%, 1%, 2%, maybe even less. So for example, I have a weak acid. This is a weak acid. This is all H plus ions. It has H plus combined with something. For example, this whole thing is HA. The moment I put in water, you see only 50% of this, in this case, broke into H plus ions. Others are still there. So in case of weak acid, the ionization is not complete, and that's why equilibrium exists. The reaction can happen both in forward and backward direction. Correct. Same thing with the base. The base, strong base, it ionizes completely. So there is a one-side reaction. There is no equilibrium here. But in case of weak base, it partially dissociates, and equilibrium exists in this case. So when we talk about equilibrium, we have to talk about weak acid and weak base only, right? Weak acid, base. So in the ionization of acid and base, we will study following things. We will study the ionization constant of water and its ionic product. We will study pH scale. We will also study ionization constant of the weak acid, that is Ka. We will study the ionization constant of the weak base, that is Kb. Relationship between K and K we will try to find. We will study some di and poly basic acids which has more than one H plus ions to give, example H2SO4, and also we'll also study di and polyacidic bases. We'll study the factors that affect the acid strength. As I told, some acid have 10% get ionized, some 20%, some 30%, right? The percent value. So what are the factors which determine the strength of the acid? We'll talk about that. We'll also talk about the ion effect in the ionization of acid and base, where you add some ions and the ionization is impacted. And we'll also talk about the hydrolysis of salt and pH of their solution. So we'll discuss all these things in the next few slides. Let's talk about the ionization constant of water. So as I told, water is both acid and base. So if you react both with water, you see that it is in equilibrium and it forms H3O plus and OH minus. Very common reaction we have, right? This guy acts as acid, it becomes H3O plus. It becomes this guy, conjugate base. This guy acts as a base, this becomes H3O plus because it takes H plus ion. Now if you see, if you want to find the equilibrium concentration of this, what is the value? It will be what? H3O plus ion concentration into OH minus concentration into H2O concentration into H2O concentration. It will be 2 times, right? That will be the equilibrium constant. But as I told, that the liquids we can ignore, right? It's pure liquid, so we can ignore this part. So what I have, K is nothing but H3O plus into OH minus, and this K is a special K, and we call it Kw. That is ionization constant of water, because here we are not doing anything, we're just using water. So this has special meaning. And that's why when we talk about Kw is nothing but OH minus concentration into H plus concentration. That's all, right? So this is a special definition, and it is nothing but similar to K, which we have discussed, the equilibrium constant. But since it is water and it has only H plus and OH minus ion, we give a special name called Kw for water, correct? And if you see here, Kw is nothing but ionic product of water, just a special name. The moment you talk about Kw in numericals, you will see the moment you think of Kw, you have to say H plus ion into OH minus ion concentration. and it has been found experimentally that the concentration of H plus and OH minus ion is 10 to the power minus 7 mole at 298 Kelvin. That's why you see it's a very weak acid and very weak base, because if you see this guy, if you give 10 to the power 7 moles of water here, only 1 mole of the water will break into H plus and OH minus ion. So if you see, if I write like this, H plus and OH minus ion, same reaction, same actually, but the same. So if I give 10 to the power 7 moles of water here, only 1 mole is getting converted. If you see, the percentage is very, very, very less, right? That's why you don't even realize that there is H plus and OH minus ion there, and we consider it as a neutral, because see, 10 to the power minus 7. I mean, if you have 10 to the power 7, that is a huge number, right? A huge number of water molecules you have. Out of that, only 1 molecule will break into H plus ions. Correct? This is found experimentally, and this happens at 298 Kelvin. So if you see, this Kw is dependent on temperature. If you see, Kw is temperature dependent. If you see, the earlier constant also we have talked about equilibrium constant, they are also temperature dependent. This guy is also temperature dependent, because this is also nothing but equilibrium constant, but we have just given a fancy name Kw, and that implies H plus ions into OH minus ions. So Kw, if you want to find, is nothing but S3O H plus ions into OH minus ion concentration. So both are 10 to the power minus 7. So you find the value, this becomes 10 to the power minus 14 molarity square. This is the Kw unit. Is known, Kw value is nothing but 10 to the power minus 14 molarity square, moles per liter square. So if you want to find the ratio of dissociated H plus ions, if you see, if you want to find the percentage of dissociation, you see that the molarity of the pure water is 55.55 moles molarity, right? So if you see, you want to find the ratio of undissociated water, that is nothing but 10 to the power minus 7 by this, because we had this much molarity water here. Actually this was if you take 5.55 molarity water, 10 to the power minus 7 becomes H plus ions, correct? Because the molarity of the pure water is 55.55 m. So from this you get this much H plus ion. So you want to find the ratio to this by this is equal to nothing but 2 into 10 to the power minus 9. That is the ratio of dissociated water to undissociated water. And this is something we know. If you want to make system acidic, the H plus ion concentration has to be more than OH minus ion. For a neutral system, the H plus ions and OH minus concentration is same. For a basic system, OH minus concentration is more than H plus ion. This is the table, right? For acidic, H plus ion concentration. See, when I say something is acidic, it doesn't mean it doesn't have OH minus ion. It may have H plus ion also, OH minus ion also. The only thing is H plus ions concentration is more than OH minus ion. That means the system is acidic. If OH minus ion concentration is more than H plus ion, the system is basic. And if H plus ion concentration is equal to OH minus ion, we say it is neutral. For example, in case of pure water, the H plus ion concentration is 10 to the power minus 7 and m, and OH minus ion is also 10 to the power minus 7 m at 298 Kelvin. So the water is neutral, pure water is neutral at 298 Kelvin. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.